Alright guys, welcome back to SQC tutorials. In this video we are going to talk about Bernoulli differential equation. I didn't write it there, sorry. Bernoulli differential equation. And this is how Bernoulli differential equation is. If I remove this, it's just like the last video we did, which was on first order linear differential equation. But once I put this becomes Bernoulli differential equation. So the difference is just that in Bernoulli there's a y here, y raised to power anything. But I had to come up with a formula that will help you. I didn't see that formula in your textbook. I didn't see it in any textbook, but I had to derive the formula so that once I give you, you'll be getting the answer straight without stressing yourself. Now, the same way we did the other one with integrating factor, we'll do this. If we were to follow the normal procedure, you would have to do some manipulations and convert this equation to a first order linear differential equation before you can solve. But you will not have this term in your exam, especially the pharmacy students. You will not have this term in your exam. But just in case you are interested in how I was able to derive this formula, I will drop the link to the description of this video so that you can also watch it and have an idea of it. You can have a fuller knowledge of Bernoulli differential equation. Now, the general solution of a Bernoulli differential equation is giving us the integrating factor times y raised to power 1 minus n. Now, in our former video, it was just y, but in this Bernoulli, it will be y raised to power 1 minus n equals to 1 minus n times integral of the integrating factor times q of x, then dx plus our constant a. Now, in this particular video, your integrating factor is not just exponential p of x dx. Now, for Bernoulli, your integrating factor will change to exponential 1 minus n integral of p of x. Now, this is your new integrating factor. Now, remember in our previous video that this part was not here. So what it means is that n is actually 0 in that video. So y raised to power 0 is 1. So if I impute n as 0 here, I will have 1 minus 0, which is I times y. Then 1 minus 0, which is just 1. So this part will be out, this part will be out. And this looks like the general equation for the previous video we did. But for Bernoulli, because there is an n here that is making it different, we have something like this. So take note of this formula. It is very, very important that our integrating factor has changed. This becomes our integrating factor, and this becomes what we use here. Instead of y, we have y raised to power 1 minus n. So quickly, let's just solve one question on Bernoulli differential equation. So for all the questions we solved in our last video on first order linear differential equation, you can actually use this formula, but in that case your n becomes 0. So quickly, let's solve one question. Okay, we have x dy over dx plus y equals to y squared. Now, we want it to be of this form, so it means that dy over dx must stand alone. So I will have to divide through by x. So we are going to have dy over dx plus y over x equals to y squared over x. Now, when you compare this and this, you find out that your p of x is 1 over x, and your q of x is 1 over x. Your q of x is 1 over x, and your n is 2. Don't forget y squared, y raised to power n. So we have gotten what we need. Now, don't forget our integrating factor is exponential 1 minus n. So we have 1 minus 2, which is minus 1. Then we have integral of p of x. Now, integral of 1 over x dx. Now, when you integrate 1 over x, you are going to get lim x. So we have lim x. Now, when I take this minus 1 up, I will have exponential lim 1 over x. When I take this minus 1 up, I will have x to the power minus 1, which in turn changes to 1 over x. Now, since we have gotten this, we will now move over. Now, remember I said when you have a raised to power in logarithm, when you have a raised to power log b base a, if the base and this are the same thing, they can cancel out to give you just b. So because this is log base e, the e will cancel out with this log e, so you are left with 1 over x. So it means that our integrating factor is actually 1 over x. Now we have gotten our integrating factor. Now let's substitute it back here. So we have the general solution as integrating factor, which is 1 over x times y raised to power 1 minus 2. Don't forget n is 2, so that's y raised to power minus 1 equals 1 minus 2, which is minus 1. Then we have integral of 1 over x. Our integrating factor is 1 over x. Our q of x is also 1 over x dx plus our constant. So we have 1 over xy is equals to minus integral of 1 over x squared dx plus a. Now if I integrate 1 over x squared, I'm going to get x is to the power minus 2 plus 1 minus 2 plus 1, then plus our constant. So this is 1 over xy. Please ensure to watch my differential equation, integral calculus video. So this is minus x is to the power minus 1 all over minus 1. They will cancel out plus a. So this implies that we have 1 over xy equals to 1 over x plus a. Now if I multiply through by x, not xy, if I multiply through by x, if I multiply through by x, multiply through by x, multiply through by x, this x will cancel out, this x will cancel out. We are left with 1 over y is equals to 1 plus ax. You can leave your answer like this, or you can find y, which is 1 over 1 plus ax. That means I flip this, I will also do this. So this becomes our general solution for this differential equation. So that will be all for this video. In our next video, we will most likely talk about first order homogeneous differential equation, then the ones that may not be homogeneous but you can reduce them to homogeneous. Please do not forget to like and subscribe to our YouTube channel. Follow us on Telegram, follow us on Twitter, follow us on YouTube, follow us on Facebook, and every other social media you can think of. If you can't find exclusive tutorial in that social media handle, please off your phone and remove it. The social media handle is not good enough. Thanks for watching. See you in our next class.